Hey guys, welcome back to the LearnAPCalc series here at LearnAP. In this video we're going to talk about related rates. This is a very tricky subject, so you may want to watch this video a couple times. And there's no one way to do related rates problems. So honestly, probably the best way to learn is to do practice problems. So if you're not getting it, just continue to do practice, and you should get better as time goes on. This wasn't easy for me to learn either, but eventually after doing sort of a lot of practice, you understand the ideas behind a related rates problem. Now before I get going, I just want to say if you guys know somebody who might appreciate our videos, we'd really appreciate a recommendation. Also, if you guys have any questions on the video, be sure to leave a comment and I will answer you as soon as possible. So let's get to it. Alright, so if you're unfamiliar, a related rates problem involves finding the rate of change of one quantity from the rate of change of other known quantities. So let's take an example here. Air is being pumped into a spherical balloon at a rate of 3 centimeters cubed per second. When the balloon's radius is 25 centimeters, how fast is the radius increasing? So here we're trying to find a rate of change from a known rate of change. So if you guys think you know how to do this, you can pause your video, but I haven't actually discussed how you go about solving this, so otherwise feel free not to pause and just watch this. Alright, so I find the first thing to do in problems like these is to draw the picture. So air is being pumped into a spherical balloon. So I have a sphere, we'll say of radius r, and I want to know, as the radius is 25 centimeters, how fast is our radius increasing? Well, so my balloon also has a volume of 4/3 pi r cubed, volume of the sphere. And so what I want to do here is do implicit differentiation. So dv dt, so anytime I encounter a variable, I'm going to take the derivative of that variable and then write that variable dt, or with respect to time. 4/3 pi is, so I'll take the derivative of r, multiply by 3, that's just going to come out to 4 pi r squared dr dt. And so now I want to plug in my givens into this. So air is being pumped in at a rate of 3 centimeters cubed per second. That's a volume. So I can plug that in for dv dt. 4 pi, and I'm asking at radius 25 centimeters. So I'll plug in 25 here. And I'm looking for dr dt. So now I can just solve for dr dt. So first thing I want to do is just figure out what this is on the left, or on the right, sorry. 25 times 25, 625 times 4 times pi, comes out to about 7,850, and if I divide 3 by 7,850, I get 0.0003. I'm sorry, 4, so I want to round. And this is the rate of change of the radius, centimeters per second. And that's important, since my radius is in centimeters and my rate of change is in terms of seconds. That's how I know this unit. So this is a very basic related rates problem where I'm first drawing out the picture, I'm getting my equation, I'll take the implicit derivative of that, find that, and then plug in my knowns. Now a lot of times you'll have things in here that you don't know, and when you do, you need to get another equation and substitute in for that variable that you don't know with one that you do know. Alright, so let's move on to another practice problem. Alright, so let's look at the second example. Sand is being poured into a conical pile at a rate of 40 feet cubed per hour. The pile's radius is always half of its height. How fast is the height increasing when the sand is 5 feet deep? So here I'll draw my picture. I have sand being poured in to my pile, which in this case is coming out to a perfect cone of radius, I'll just say, of radius r and height h. Alright, so I drew my picture, and now I want to draw out my equations. So I want to find the equation for volume of a cone. And that comes out to be V equals 1/3 pi r squared h. Okay, and so here I also know that my radius is half of the height. And now, before I take a derivative, I want to think about this. I'm trying to find the rate of change of the height with respect to time, dh dt. I'm given the amount of sand being poured in, which is the rate of change of the volume. So if I take this derivative, I'm going to end up with dr dt in here, and that's not given. So I'm going to want to substitute something in for r with something known. And that's given right here. The radius is half the height. So let me plug that in for r. And then I'll simplify this. So this would be 1/12 pi h cubed. Now I can take my derivative implicitly. dv dt equals 3/12 is going to simplify to 1/4 pi h squared dh dt. So again, I'm just taking my derivative of v, which is 1, times dv dt, and then my derivative of h cubed, which is 3h squared, and that's going to come out to 3/12 1/4 times dh dt. Okay, so now I can plug in my knowns. My rate of change of the volume is 40 feet cubed per hour. And I'm asking when the depth is 5 feet deep, or my height. So h equals 5. And then I'm solving for dh dt. And so here, if I sort of multiply this through and solve for dh dt, 1/4, multiply that by 40, I get 160, divided by 25 is 6.4 divided by pi, and this is going to come out to about 2.037. And now I want to think about, well, what are my units? So height is given by feet, because again, sand is 5 feet deep. So I know this is feet per some unit of time. And since this is given per hour, the same is going to be given by my dh dt. So the answer is that when the sand is 5 feet deep, the height is increasing at a rate of 2.037 feet per hour. And just a quick general note, for AP Calculus, you should normally write everything to 3 decimal places if you're sort of rounding. It's best to keep a fraction, but 3 decimal places is usually fine, unless otherwise stated. Alright, so that brings me to today's challenge problem, and this is a related rates problem. A ladder is 15 feet long and is leaning against a wall. The ladder then slides away from the wall at a rate of 3 feet per second. Now when the ladder is 9 feet from the wall, how fast is the ladder moving down the wall? The solution to this is on our website, learn-ap.com, and I'll also put a direct link in the description. If you guys found this video helpful, please take the 2 seconds it takes to hit that like button. That just helps us know that we're putting out content that's useful and that you guys want more videos. We also do live streams every Sunday from 4 to 5 p.m. Eastern where we answer your questions about AP Calc, and we also have chem ones from 5 to 6 p.m. Eastern if you're taking chem. You can like us on Facebook or follow us on Twitter so that you never miss a live stream and we sort of post announcements there. Links for that will also be in the description. If you're confused about any of this stuff, you can leave a comment or ask in the live stream. Other than that, I want to thank you guys for watching, and I'll see you in the next video.